Hi there folks, this is the midterm review, and as always I am the amazing Mr. Jansen, so away we go. If we take a look at this first one, it's asking us to write the equation of the line, and the two things we need to write the equation of the line are the slope and the y-intercept. Since we have a line that's parallel to this thing, this line has a slope of 3, parallel lines have the same slope, so our line is also going to have the slope of 3. And then we use a fresh y equals mx plus b, and we plug in what we know. I know the slope is 3. I've got an x and a y value right here, this ordered pair. So I plug the 1 in for x. I plug the negative 2 in for y. And then we just solve this for b. So I find out that b equals a negative 5, which means the equation of my line is y equals a 3x minus 5. And that's it. Number 2 is very similar. I still need to find the slope and the y-intercept. The only difference is this time I'm given a line that's perpendicular. So this line has a slope of 1/2 perpendicular. I do the opposite reciprocal. So I change it from a positive to a negative. And I change it from a 1/2 to a 2/1. So I make it a negative 2. So I change the sign and flip it. And then I still do the same thing. I fresh y equals mx plus b. Plugging in what I know. I know the slope. I know the x and the y value, because once again I'm given an ordered pair here, so I plug in the negative 4 and the positive 3. That's going to give me a 3 equals a positive 8. That's terrible looking. Let me try again. A positive 8 plus b. I subtract the 3 from each side, or sorry, I subtract the 8 from each side. So I find out that b equals a negative 5. It's strange because I got a negative 5 in the previous example as well. I apologize. So anyway, I get y equals a negative 2x minus 5. And that's it. Number 3, I'm doing the same thing once again. So I'm doing the slope and the y-intercept. The slope this time I have to use my slope formula. Right here the y value was a negative 2. Now it's a positive 10. That's gone up 12. Here the x value is a 1, now it's a 4, it's gone up 3. So my slope is 12/3, which is 4. And then I do the same thing I've done a couple times now. I plug in the slope and the slope here, which is a 4. I plug in an x and a y value, which I can use either one of these ordered pairs. I'll use the first one. So that gives me a negative 2 equals 4 plus the b. I subtract the 4 from each side, and I find out that b equals a negative 6. So the equation of my line this time is y equals 4x minus 6, and that's it. For this one, we're building a 3-foot wide sidewalk around a pool, as modeled below. I've got the length and the width of the pool, and I want to find the area of the sidewalk. So essentially what I have to do is I have to find the area of this entire thing, and then I have to subtract the area of the pool. Okay, I've got to subtract. And what I'll be left with is then the area of the sidewalk. So when I look at the overall picture of this thing, if I want the area of the whole thing, this entire side right here, the pool is 20 feet wide, and then there's 3 feet on each side, which is a total of 26. Here, this guy is 12 feet wide, plus 3 feet on each side, which is a total of 18. So the area of the whole thing, again, is length times width. And then I want to find the area of just the pool, length times width. And then essentially I'm going to subtract these two things. So here I'm going to do the 26 times the 18. That's the overall length and width. And then I'm going to subtract the area of just the pool, which is the 20 times the 12. Right? And now I just have to plug this in. So here I end up with a 468. Here I end up with a 240. And so now I just subtract these two things, and it looks like it gives me a 228. Okay, and that looks like square feet. And that's it. Okay, so we take the area of the whole thing, we subtract the area of the rectangle inside, leaves us with the sidewalk. In this one we want to evaluate, so we're just plugging these values in. So I plug the 6 in for the y, I plug the 5 in for the x. I plug the 7 in for the z, and I plug the 40 in for the w. And then I just plug away. That gives me an 11 squared plus 5 times 7 times 40. 11 squared is a 121. Here, the 5 times 7 times 40 gives me a 1400. And so that gives me 1,521. That's it. Number 6, I just have to split this into two equations here. So I'm just going to do a 3x plus 6 equals 12. But then I also do the 3x plus 6 equals a negative 12. Because essentially with an absolute value, it doesn't matter if you plug a positive 12 or a negative 12 inside there to give us a positive 12 either way. Now I just solve this. Subtracting the 6, I'll do the same thing over here. So I get 3x equals 6. Over here I get 3x equals a negative 18. I divide by 3. Again, I do the same thing over here. I'm solving the same problem practically twice and getting two very distinct solutions. And that's it. And you can plug each of those in and check them to make sure they work, and they do. For this one, I want to split it up essentially the same way. The first one looks exactly like this thing, except without the absolute value symbols. But then I also do the x minus 3, and I do a negative 9. But with an inequality, I have to flip the inequality sign, so I say less than the negative 9. And now I solve each of these just like I did in the previous example. So I find out that x is greater than 12. I also find out that x is less than a negative 6. And then from here, I have to decide if this is an and or an or. Since the absolute value is greater than, it's going to be an or, and I have to put the word or in between there or it's not complete. And I can even do a little quick sketch on a graph to check this thing. If I've got a negative 6, I want to be less than the negative 6. I want to be greater than the 12. And now I can see it looks like an or inequality. Okay? For this one, I'm just multiplying, and I just work left to right. So I multiply these first two pieces. 10 times 6 is a 60. When I multiply, I add the exponents. That's x to the third, y to the third. And now I'm going to multiply that by this second piece over here. And when I do that, again, I multiply the numbers out front. That's a negative 420. I add the exponents. That's a negative 12. That's a positive 11. And then the last thing I do here, and this is the step that we tend to forget, is remember negative exponents, I have to send those to the denominator. So these guys stay where they are, but the x to the 12th gets sent to the denominator, and then I can make it a positive exponent. That's what negative exponents do. All right? And number 9, I'm going to start inside the parentheses here. So inside the parentheses, 18 divided by a negative 9 is a negative 2. When I divide and subtract the exponents, 4 minus a negative 2 is a positive 6. That's going to be a y to the 4th and a z to the 4th. And now I can raise it all to the 5th power. That's a negative 32. I multiply the exponents. That's an x to the 30th, a y to the 20th, and a z to the 20th. And that's it. So again, start inside parentheses, do the division. When we divide, we subtract the exponents, then raise it to a power, and we multiply the exponents. Okay? For this one, I'm looking for perfect square to divide evenly into this guy. So that's going to be 16 times 2. For variables, I need variables that are exponents that are divisible by 2, so I'm going to break this into x squared times x. The y to the 8th is already a perfect square because it's got a variable that's divisible by 2. And then just start taking the square root of each of these things. The square root of 16 is a 4. The square root of x squared is an x. I'm assuming all variables are positive. The square root of y to the 8th is y to the 4th. And then still trapped under my square root is the 2 and the x. And that's it. For this one, the square root of negative 81. Really, the square root of a negative gives me an I. That's the definition of imaginary numbers. And then the square root of 81 is a 9. So it's just a 9i. Okay? And if you want to think of it this way, breaking it up into an 81 times a negative 1, the square root of 81 is 9. The square root of negative 1 is an I. And there's nothing left underneath there. Okay? For this one, I just want to use my distributive property. So I'm distributing here. Just remember stuff on the outside with stuff on the outside, inside with inside. So when I do this, I do the 3 times the 2, which is a 6. It stays on the outside. I do the 5 times the 6, which is a 30, and they stay on the inside. And they do the same thing with the next one, so that's going to be a negative 9 root 10. Now I look for perfect squares that divide evenly in here so I can try to combine like terms, but there are none, so that's it. For this one, I'm just using my distributive property. I'm foiling. So I distribute the 2. That's going to give me an 8 plus 4i. And then I distribute the negative 3i. That gives me a negative 12i minus 6i squared. And now I simplify. That's going to give me a negative 8i in the middle when I combine those like terms. But then over here, the I squared is actually a negative 1. So what I really have is 8 minus 8i plus 6, which means I have more like terms to combine. So I do 14 minus 8i. And And that's it. For this one, it asks me to factor completely. So the first thing I always look for is the greatest common factor. With this one, it's a 3, so I factor the 3 out, leaves me with an x squared minus 4. And now x squared minus 4 is a difference of squares. It factors into an x plus 2 and an x minus 2. And that's it. I can't take this any further. So now that thing is factored completely. Okay? The next one, this is a difference of cubes, which is one of our SOAP problems. Factors into a binomial and trinomial. SOAP is the signs that we plug in, the same. So this was a negative, so this is a negative. The opposite, that's a plus. And then always a plus, another plus sign. Okay? So same, opposite, always a plus. And now I just essentially take the cube root of each of these terms. The cube root of x to the third is x. The cube root of 27 is 3. And now if I square that first term is x squared, I square the last term is a 9. And then this middle term, I just take these two values, the x and the 3, and I multiply them. Gives me a 3x. Okay? We have to memorize the pattern of the signs. We have to memorize how we come up with each of those numbers. And we're just following this format. Okay? Difference or sum of cubes. This one asks us to solve, so we're going to solve either by completing the square quadratic formula or factoring. Always check factoring first. I build a bridge, a negative 10. The two numbers that multiply to a negative 10 but add to a negative 3 are negative 5 and a positive 2. So this one is going to factor into an x minus 5 and an x plus 2. And then you simply set each factor equal to 0, x minus 5 equals 0, x plus 2 equals 0. And you solve each. Here I add the 5, so x equals 5. Here I subtract the 2, x equals a negative 2. And that's it. Okay, those are my two answers. On number 17, I essentially do the same thing here. I would start off by building a bridge, see if this thing's going to factor. And it does. A 4 and a negative 3 will give me that. Two numbers that multiply to negative 12 add to a positive 1. This one I can't use my shortcut on, so I'm going to split up the middle term. 3x squared plus 4x minus 3x minus 4 equals 0. And now I can solve, factor by grouping. Out of the first group, I factor out an x. Leaves me with this. Out of the second group, I factored a negative 1. Leaves me with the 3x plus 4 again. So now my two factors are the 3x plus 4 and the x minus 1. And just like I did before, I set each factor equal to 0. I do the 3x plus 4 equals 0. I do the x minus 1 equals 0. And we should all be able to solve that from there. When I solve this first one, I find out that x equals a negative 4/3. When I solve the second one, I find out that x equals 1. And that's it. Number 18, I might start off by building a bridge and seeing this thing can factor, but I'm going to find out very quickly that it can't. So now I go to completing the square of the quadratic formula. For this one, I wouldn't do completing the square. You only want to do that when you have an a value that's 1 and a b value that's even. So I'm going to go to the quadratic formula. So I'm going to do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's a negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is negative 8, all over 2 times a, which is the 1. So that's a negative 3 plus or minus the square root of 9 plus 32, all over 2, which is a negative 3 plus or minus the square root of 41 over 2. And there's nothing else I can do there. I can't simplify that radical, so I leave it the way it is. In the next one, I build a bridge. It's not going to work. I could go right to the quadratic formula, but for this one, I'm going to do completing the square. I'm going to add the 5 to each side. Remember, completing the square, we want to create space. That's an x squared plus 2x with little space equals 5. And now I complete the square. B divided by 2 and square it gives me a 1. So I add 1 there. I do the same thing to the other side. This factors into an x plus 1 squared equals 6. Now I can solve just using the square root. I take the square root of each side. I find out that x plus 1 equals plus or minus the square root of 6. And now I can subtract the 1 from each side. And so when I do that, I find out that x equals, I've got a negative 1 and I've got a plus or minus root 6. So I write it as negative 1 plus or minus root 6. And that's it.